Hello viewers, in today's video we will learn how to use Design-Expert software. So we will just learn a few basic things about Design-Expert software. Okay, so we all know that the software Design-Expert basically is used for optimization, or you can say process optimization. So basically there are certain formats in context of the software Design-Expert. So we have CCD, which is widely used, okay, and this is a widely used experimental design for response surface methodology. So we also call this response surface methodology optimization. And PPD, whereas PPD is another format, and this related to financial transactions. So this is not an experimental design. So we have different type of forms of Design-Expert. So one of them is CCD, which is the most popular design. So if we open the new design, so here you have, click on response surface. So we have CCD. So CCD is the most popular design for fitting a quadratic model and is used for process optimization. So we have identified a few critical factors, and if you want to find the ideal settings, so you can see here we have numeric factors. You can increase the numeric factors if you want, and you can increase the categories if you want. Okay, and you need to have these non-center points as 8, center points as 5. Okay, and you have to name the variables here, and even the low one and the high one. So if you have pH, you will put this pH from 2 to 6, and the another numeric, that if you have like concentration, you can put from 20, 100. Okay, and the structure is built upon two-level factorial design. So you have a 2 factorial design, and is augmented with additional axial points, also called star points and center points. And the levels basically means, here you can see the levels. Okay, so levels basically means CCD typically uses 5 levels for each factor, and through a face center CCD can use only 3. And the purpose is the added points allow the design to effectively estimate the curvature of the response surface and provide excellent prediction capability near the center of the design space. Okay, and now if your goal is to design an experiment for process optimization, so you would use CCD. Okay, we have other formats also like BBD. So BBD is a safer mid-range that avoid extreme experimental point. Instead of axial point, BBD uses edge midpoints and multiple center points. So it is ideal when experiments at extreme temperatures like pH values or reagent concentrations. For example, we have a pollutant, so its concentration may vary from 20 to 100, may be unsafe for degrade material properties. So BBD requires fewer runs than CCD and is well suited for adsorption studies. And CCD is best suited when full optimization is required. Factors cover wide ranges and the cost of experimentation is acceptable. Now we have optimal custom design. So it is a flexible design when the factor space has irregular boundaries, constraints, or combinations that must be avoided. So it allows selection of points based on D optimal or I optimal criteria, ensuring the maximum statistical efficiency with the minimum number of experiments. So we will be focusing basically on BBD and CCD only. So we have some deductions. So use CCD when strong curvature exists, extreme testing is safe, and BBD when you want fewer runs, and custom design when the design region has restrictions, constraint, or high experimental cost. So CCD will give you the best accuracy, BBD will give the best safety and efficiency, and the custom design will give the high flexibility. So in our first video, let us see. So this is my CCD, and BBD, you can see the interface looks like this. Optimal custom design looks as it is a Design-Expert 30. Let's suppose we are using CCD or box pen. Okay, so in box pen, for example, box pen, you can see the numerical factors if you're keeping 4. So we see the variables are increasing. Okay, and category factors you can also increase. So if suppose we are putting pH, and then let's suppose 2, 6, suppose this is concentration, 20, 100, and numeric if suppose we are putting this time, so temperature, this is let's suppose 5, 10. Okay, now after this you can click on next, and then R1 for example you want just removal, and if you want more responses you can just click on this, then let's suppose adsorption capacity, you can also put the unit, for example you want to put percentage, then you can put this milligram per gram. Now this is your whole set of experiments that you want to run. So you have a run of around 17, and this is your factor 1, factor 2, factor 3, and these are your responses. Okay, so this is all about the first video. Will be restricting about the entering of the data, and the least discussion was CCD and BBD.